We're going to start talking about functions. So you have to first know what functions are. So the textbook definition is a relation in which each element of the domain is paired with exactly one element of the range. So let's break this apart. When we're talking about relation, we're talking about an x and a y, so a coordinate pair. When we think about element of the domain, so in your homework you talked about domain. Domains are always the x's. So let's label those for us so we know they're the x's. Think about if you have an ex-friend or maybe an ex-boyfriend or girlfriend. They're your ex. And sometimes we get a little aggravated with them and we think, that dang X. So remember D for domain, dang X. Domain are your X's. Is paired with exactly one element of the range. So if domain is X, then you know that the range is the Y value in the coordinate. Think about a function as a rule. So if you've ever been to one of those machines where you put in a quarter and a penny and it smashes it into something to make you remember that area that you went to visit, when you put in the quarter, that is the input. The rule that happens inside, so it turned it to a beautiful Statue of Liberty, is the rule that's going to happen. Every time that you put in a penny with a quarter, out will pop out a little coin with the Statue of Liberty on it. Well, of course, cannot draw a Statue of Liberty on this little bitty circle. So a Statue of Liberty. If we were to put in the same coin and we pop out a little, let's say a cat, then obviously that is no longer a function. That machine is broken and it is not working. So we've got to remember there's one input and the same output every time we put that same input in. So we're going to do some examples so you can see the different types of functions that you may see and how you can identify them. All right, so here's some examples that we're going to go through and see, can you determine whether or not they are functions? So the first one on A, we have a table, and if you'll notice that every domain, so every x, when we put in here a -3, we get out of 5. When we put in a 2, we get out of 6. And when we put in a 4, we get out of 7. So it fits our definition of every domain has its own range. So it's one pair. So this would be a function. In example B, we have mapping. And notice mapping, they put them a little bit different and they use lines to connect. And these can get very confusing looking, you'll see in a further example. These are very straightforward. -2, when we put in the machine, comes out as 2. -1 is -5, 0 is 0, and 1 is 2. Notice that no x's repeat, but we do have some repeating y's. And it's okay as long as they are not x's. Y's can repeat. You can put in a -2 and get out 2. You could put in a 1 and get out a 2. So those are different machines and those are functioning. Whenever we put in a 1, we get out a 2 every time. Now, if we were to put in a -2 and get out a regular, say, -5, then that would not be a function. It can't give us two different things. So this is this is a function. All right, down here you have some ordered pairs. So we look here at all of our x's first. This is a strategy that you can use. Remember, for a function, the x's cannot repeat and give you something different. And I notice really quickly that I have 2 zeros for my x's here in my domains. This x will give me a 4 range, and this gives me a 1. Well, that machine is obviously broken, because if I put in a 0, I should pop out a 4, but then I put in a 0 again, I can't get out a 1, and it to be a function. So this is not a function, no function. Here's another table. So take a second and look at that and see what you notice. Pretty quickly you should notice that we have a 2 and a 2, so I have x's repeating. That should clue you in immediately to start thinking, let's see if they're giving me the same thing. So 2 gives me 4, great. That means the next 2 should give me 4, but it doesn't. It gives me a 3, so this is not a function. Here's another example of a mapping where we got a little bit more crisscross going on. Sometimes our eyes will play tricks on us, so a good idea to do is think about what it's connecting to and write them as ordered pairs. So I have a -3 going to a 1. I notice also I have a -3 going to a 0. Immediately I should stop and notice that my x's are repeating and they're going to two different ranges. So this is not a function. Here we have two more tables. F, quite a few different ones, and the first thing you should clue yourself in on is, are any x's repeating? So if we look, -1, don't see that, -3, oh, I see that again. So -3 is repeating. So don't immediately stop and say it's not a function. Look a little further. As we look over, it gives me a -2. That means every time I put in a -3, I should get out a -2. And I do. So this is a function. If you'll notice, almost on the y side, we have 2, 2, a -2, and a -2. Remember, they can repeat. 2 and 2 can repeat. There's different inputs. The outputs are okay. It's okay for the ranges to repeat, not the domains. All right. On G, we have nothing that looks like repeating, so that looks good. But I notice that I have lots of y's that are repeating. Is that okay? Yes, it's okay. This is a function. So it is okay to have your y's repeating. You just cannot have your x's repeating. All right, let's look at a couple more. So here's another one where they're coordinate pairs. First thing you need to do, look at all your x's and notice, are they repeating? I don't see any repeating, so automatically, yes. All right, another mapping. Remember the strategy? Start making your ordered pairs. So 3 goes with 0. 3 also has a line coming off of it going to 2. So immediately I see x's repeating. We don't want that to happen, and they go to something different, so we know that is not a function. You also can see them in coordinate planes, and there's a really simple test to do that we're going to write down in just a second to see if they're a function. Remember, we don't want the x's to repeat and give us something different. So these are not lines so that you know what the coordinates are, but if you would look and see, you could actually kind of figure out possibly what that ordered pair would be and so forth. On this one, I didn't give you enough information to find that out, so we're going to use something called a vertical line test. So you literally can take a straight line or your finger or your pencil, and when you go reading left to right across the graph, you want to read always from the side, and you hold your pencil up this way. See if I can get my little straight to work. And as you move across the page, think about little bitty lines coming across. If your pencil or your finger hits more than one dot at the same time, that is not a function. No. No function. So when we do the same thing here, if I take a straight line or my finger and I start running it down the page, I notice it's only hitting the line that I have drawn one time at a time. So this is a function. So let's try L. So straight lines, immediately it's hitting more than one point. It's hitting this point here and this point here. The lines of the graph don't matter, but it's hitting these 2 points. So therefore, it is not a function. All right, let's try our final one. This is an example of a parabola that you get from quadratics. So you'll see this eventually again. Now my marker is a little fat, but it is at a perfect angle. It's making a U-shaped. And if we look, it's hitting a spot here, nowhere else. It's hitting a spot here, nowhere else. This is a function. So write this in your notes, vertical line test. We use it for graphing, and it tells us immediately whether or not it's a function. It would not be a function if a point crosses the line more than once. Remember, we have to keep it vertical, so we're talking about a vertical line. Let's get a color to help us remember that. And we're talking about a vertical line straight up and down. We want to read left to right on our graph, and if it crosses more than one point, then it would not be a function. Now we're going to change our train of thought here to evaluating functions. So you might see some notations as these above. So f of x, notice it's in parentheses here, f of negative 2, g of x, h of a. These all are just another way to say y. So we're saying what y could be, and they call it f of something or g of something to tell us it's a function. That is something that has been spit out of the machine, out of the rule machine, because we did something to it. So we're going to do our first example, and you'll understand a little bit better. So here is a function rule. F of x equals negative 3x minus 10. So I want to find what is f of x, what is the rule when, or what is the solution? The rule is here. What is the solution when f, the function is 4? That means everywhere that I see x, I'm going to put in 4. So in this case, I would rewrite f of 4 is equal to negative 3. I'm going to insert my 4 into where my x is, minus 10. Remember, we're just trying to figure out what f of 4 is, which is another name for y. So negative 3 times 4 gives me negative 12 minus 10. So f of 4 is equal to a negative 22. All right, we're going to use the same rule here. As you'll see, over to the side, we have the rule of negative 3x minus 10, same as the first one. But this time, we're finding f of negative 2. So when our x's are negative 2, what is our output? So we're trying to find our output here. This is our output. And so we're going to plug in negative 2 everywhere we see x. So negative 3 times negative 2 minus 10 is going to give us f of, or our output, when our input is negative 2. So negative 3 times negative 2 gives us 6 minus 10. So our f of negative 2, or our output rule, or output when our rule is negative 3x minus 2, when our input is negative 2, is going to give us a negative 4. This would be our answer. All right, let's try something a little bit more complex. You get used to seeing f of, but it's not always necessarily going to be the case. Remember at the beginning I told you it can be written as many different ways. So let's try another one. So C, we're going to do g of x, and this is going to be our rule. 2x squared minus 5. So in this case, I want you to find what the output would be when we have the input g of negative 1. So this is, what will it be when we have g of negative 1? So that means everywhere we see x, we put in negative 1. So g of negative 1 is equal to 2. Use parentheses here. It's very important because squares can throw people off. Remember, we have to follow order of operations. And then minus 5. So the first thing we do here is we're going to go ahead and take care of the exponent. So g of negative 1 stays. It's just kind of like saying what is y, is equal to 2, a negative 1 times a negative 1 is equal to 1, minus 5. Then our next level of order of operations is multiplying the parentheses. So 2 times 1 is 2, minus 5. And then we have 2 minus 5 gives us a negative 3. So g of negative 1 is equal to negative 3. All right, so we're going to move up to a 3 star. I'm sorry about the buzzing in the background. They're doing a little fire drill check. So we're going to move over to a 3 star. So this is D. This is going to be our 3 star. And I'm going to give you 2 rules on this problem. So our first one is f of x, and our rule is going to be x plus 5. And our second rule is going to be g of x, and that rule is going to be 2x minus 4. So now what I want you to find, I'm going to use a different color here, I want you to find f of 2 plus g of negative 2. So this can get a little weird looking. Go in simple order. Do not try to do it all at one time. Remember, every elephant can be eaten by one bite, even though we don't eat elephants. So we are going to first take in and think about our f rule here, our f of rule. And here we know that it's going to be 2 that we put in. So we're going to plug in our input, f of 2, into our rule problem. So where we see x, we put in 2. So 2 plus 5. And then we know f of 2 is equal to 7. Then we're going to pause for a second, and we're going to go to the other side of our problem, and we're going to solve the g of negative 2. So we're going to, remember these are being added, so we're doing g of negative 2, placing it into our rule, and then we're going to go ahead and solve. A negative 2 times 2 is a negative 4. And a negative 4 and a negative 4 together gives us a negative 8. So g of negative 2 is equal to negative 8. So now we look at what we have accomplished from these two, and we have 7 and a negative 8, and we were adding together, so 7 plus negative 8 is equal to negative 1. So when we're trying to find what f of 2 plus g of negative 2 is, with these rules as our f of x and our g of x, then we know our answer is negative 1. So there's your 3 star. All right, so we're going to go and do a little bit harder. This is going to be probably about a 6 star. This is the highest we're going to go today. So I want you to try it and then pause the video and then continue to play. So I'm going to give you the rule. This one, let's make sure I had D, so we're on E. So this was E. And our rules are going to be f of x. And this is a cursive F. You'll see them mostly like that. I know some of you don't do cursive that well, but try. You'll get really good at it. All right, so our f of x rule is x plus 5. Our g of x rule is going to be 2x minus 4. All right, so what we're going to do now is we're going to find f, we're going to do parentheses, g of 2, close parentheses. So we've got to think about what we're doing first. When we do order of operations, we always think about what is inside the bracket first. Think about yourself being a rat, trying to get out of the bag, then to get out of the box. So in this case, we're going to look at our first g of 2. So we're going to look here first. So we're going to solve this one. So we're going to do g of 2 and use g of's rule is equal to 2 times 2 minus 4. So we're going to get 2 times 2 is 4 minus 4. G of 2 is equal to 0. Now, this whole piece that we'd already determined here, this whole piece here, we've solved, and we know it is 0. So that 0 gets in place here. This turns into a 0, and now we're actually looking for f of 0. So now that we know what g of 2 is, that is used in the place of the input for f's rule. So f of 0 is equal to, everywhere we see x, we put in what we're using for our function rule, 0 plus 5, and we know that that answer is 5. So then our final f of g of 2 is equal to 5. This would be your answer. All right, now this was a 6 star. Put your stars or not. But this is as hard as we're going to go today. So you have some practice to do. So try your best. There's a key. And we'll go over some more tomorrow.